right, we are on lesson 4, which is talking about exponential functions and their transformations. A key part of this lesson is going to be remembering our exponent rules. So there's a quick summary at the top of exponent rules that you need to read. Make sure you read them so you remember those rules. They're going to come into play here. Once you've read those, please try example 1, where it's just asking you to describe the transformations that have occurred. As a reminder, these transformations are following this formula where H and K are translations and A could cause reflections or dilations. Try out number 1. We'll go over them in just. All right, you should have tried those out. Hopefully your world's not upside down like mine currently is. However, here are the answers. This one, y equals 4 to the x power is shifted 2 units left. 2 to the x power is horizontally dilated by a factor of 1/3. In this case, y is equal to 9 to the x power was horizontally dilated by a factor of 2. Notice, x transformations are always reversed and they are horizontal because x values are horizontal. D, 5 to the x power is translated 1 unit right, again, reversing the signs. If there was a k value on the end, that would shift up and down, and it wouldn't be reversed in sign. Now, look at the example from 1a. Remember, we had 4 to the x plus 2 power. If I use the rules that you read about, the product property lets me rewrite this as 4 to the x power times 4 squared, which then becomes 4 squared is 16 times 4 to the x power. So that means that this horizontal shift left 2 moved our x-intercept. So if you take a look at this original exponential function, this 16 is now our a value, which is the initial value. When we took an exponential, and it usually passes at 1, right? But because we shifted this to the left, where do we now intersect? What's the initial value? It's now 16 because this moved, in this case, 2 spaces left. So that gave 4 squared the chance to catch up here to 16. So you'll notice that when you have a transformation here, it's also affecting this y-intercept. Now, every horizontal translation of an exponential function, so anytime you have an h value, it's equivalent to a vertical dilation. So, did you notice here, these were all horizontal dilations? And that is because a translation causes a vertical dilation, because it's going to change the initial value from 1 to a new value. Let's look at this. Example 2. Each of the following exponential functions has a horizontal translation. We want to write the equivalent representation that has a vertical dilation and no horizontal. So, in this case, right now the horizontal, this one shifts left 3. But if I rewrite that, that's the same as 2 squared times, 2, this is the same as 2 to the x times 2 to the third. Now, I did that using the rules that we have. I'll rewrite now 2 to the third as 8 times 2 to the x power. Now, if I have f of x in this form, I can see my a value here, my initial value. This one will cross the y-axis, the y-intercept at 8, because when I plug in 0, it makes this 1. So that no longer has a horizontal shift. It became a vertical stretch where the intersection at the y-axis went from 1 to 8. Try out B and then C. C is definitely a little more tricky. We'll go over these in just a moment. All right, take a look at B and C. Key thing in B is that 3 to the negative 2 power became 1 over 3 squared. The negative 2 turns into a fraction, which gave us 1/9. So since this one moved to the right, the y-intercept got smaller, down to 1/9. Over here, this one, the 4 stayed out front. When I factored out the 3 squared, that became 9. 9 times 4 gave me 36. So this one here already had an initial value of 4 at the y-intercept, which now, because of that 2, became 36, because we shifted it 2 to the left, making it a larger value. On the next page, now, how would I apply the power property? Which of the following is equivalent to 9 to the 2x power? In this case, having these multiplied together using the power property would be 2 times 9 to the x. Oop, nope, sorry. That's the previous property, to the x power. Now, if I do this, I could do 9 squared. That is definitely something I could do, which would be 81, and now that x is still outside. So, essentially, when these are multiplied, it's the same as raising a power to a power. So I separated those powers, and 9 squared is 81, so the answer there was D. Try this one out. Which of these could be equivalent to 4 to the x? Well, 9 times 4 to the x, I have to think through this. I notice that these have a 16, and the 9 could become a 3 or a 9. Let's keep 9. Let's focus on the 4. 4 to the x. If I wanted to make 4 into a 16, that means it got bigger, so the exponent would be smaller. So 16 to what power is 4? Well, square root of 16 equals 4. Square root is 1/2, so 16 to the 1/2 power to the x power. So which of those represents that? Well, if I multiply x times 1/2, I get 16 to the x over 2 power. So the 9 doesn't change at all because it wouldn't have a common base, even if I made it an exponent like 3 squared. No common base, so I can't use it. The answer here is C. All right, show up to class with any questions you've got. These should be review. If not, that's okay. But do your homework. Make sure that you follow up with any questions you've got. And Mr. Warner out. If I can find the button. Give me a sec.